All right, in this part of the weekly wrap-up, I just wanted to focus in a little bit more on the esters, amides, and nitriles, and kind of like a substitution reaction that occurs on them, which is A, either the formation of an ester, or B, the hydrolysis of an ester, and then we're just looking at the hydrolysis of amides and nitriles. And there are a couple of tricky things in there, so I'm hoping to do just a few things with that. All right, this is the name of an ester which I expect you to be able to draw out by now. Isopropyl butanoate. It's the isopropyl ester of butanoic acid. So in order to draw it out, we just draw out butanoic acid. All right, it would be the butanoic acid if there was an H there, but we don't have an H over there. 1, 2, 3, 4. We don't have an H over there. We've got an isopropyl group, which is the substituent, and that looks like that. All right, so it's kind of like, okay, that's our acid parts, all right, and this is our substituent, okay, isopropanol part is over there. All right, if we hydrolyze these and we use, for instance, acid, some sort of acid plus lots and lots of water, then the product that we get will be the butanoic acid, all right, plus isopropanol. All right, you see how in the names, if we hydrolyze an ester, what we're getting is the first part, so we get isopropanol, right? We get isopropanol and butanoic acid. All right, it comes out of the name, so we can look at this and we should recognize this is the bond that we are breaking. Okay, so hopefully that you can see a bit of this. Now, the way that this occurs, there's a bit of a mechanism that's involved, and it's quite an involved one. But what I want to do is the mechanism for the base hydrolysis. All right, not the acid one, but where we use base. And the point here is that when we use base, our product can no longer be an OH because the base is going to pick up that H, because this is a carboxylic acid, and so we end up with the carboxylate, and we end up with the isopropanol like that. So under base conditions, it is slightly different, and it actually becomes more clear if we do the mechanism. Now, you don't need to know the mechanism of this, but I'm only doing it just to show you that where this actually comes from. So if we take our butanoic acid, what happens is that our base, we know, is a good nucleophile, and although it doesn't look like there's any electrophilic positions on this molecule, there is in fact one. It's this carbon here, because the carbon-oxygen pi bond is fairly weak, and oxygen is more electronegative. In other words, it's drawing electrons away from it, all right, from the carbon. We can actually add the base to that carbon if we break this carbon-oxygen bond, which is a pi bond and is easy to break. It's kind of like an addition reaction, and what we get then out of that is something that looks like this, O isopropyl and OH. All right, so there's the base going in, and there it is over there in the mechanism. Of course, what I've made a mistake of is I have not put the minus charge on the oxygen. When this happens, this is actually quite unstable. It's called a tetrahedral intermediate, and it is unstable, and the negative charge on the oxygen wants to come back in and form a pi bond because it's got nowhere else to go. So when it does that, in order to do that, it's got to break a bond. It's not going to break a carbon-carbon bond. We don't do that. Please never break carbon-carbon bonds. It can either break this carbon-oxygen bond. If it breaks this bond, then we go back to the starting material. But if we break this bond, we kick out the isopropyl substituent part. And so the product of this is the isopropyl oxide. So look again, yeah, this is where the nucleophile was. It's now formed this. The problem with this as the final product, all right, is that isopropyl oxide, this which was kicked out, it's an O minus and it's a very, very strong base. And here we have an acid, and so this is not the final product. What has to happen is it has to go and pick up that H over there, and it gives us the final product there. So actually, in effect, this OH is this oxygen there and that hydrogen over there. All right. That's more technical details than you need, but I'm hoping that you can see it might help some of you to see how the hydrolysis of an ester with a base ends up looking. All right. And then in the rest of the class, we looked at very similar sorts of things. If I drew out butane amide, we can also hydrolyze this. And once again, an amide is made up of two parts. We're made up of sort of the amine part, and we're made up of an acid part as well. And here, when we hydrolyze it either under acid conditions or under base conditions, we get two slightly different products, which are based on whether we are acidic or basic in the hydrolysis. We're going to be breaking this bond over there, and so we form our acid, OH, and our nitrogen, NH. Now here's the one trick, is it should be NH3, ammonia, but it's under acid conditions, and so ammonia will be protonated, and it's NH4 plus. All right, remember, if you take NH3 plus H3O plus, it's an equilibrium that lies very much in favor of NH4 plus and plus H2O. All right, if you go and look at your pKa tables, you'll be able to work that out. All right, so that's why we end up with an NH4 over there. Under basic conditions, we end up with, again, very similar to that ester hydrolysis, we end up with an O minus. It's a carboxylate, not the carboxylic acid, and we end up with NH3, ammonia, which is the stable intermediate. All right. And then lastly, we had butane nitrile, which is 1, 2, 3 bonds. All right, carbon to a nitrogen. This is butane nitrile. And we have the same thing where we can go acid and base. And again, the hydrolysis is occurring with, it's the nitrogen and 1, 2, 3, 4 carbons going over there. We're actually breaking this triple bond over here. And so we end up with, again, if we're under acid conditions, water, we end up with the carboxylic acid plus NH4 plus, and under basic conditions, we end up with the carboxylate, O minus plus NH3. All right. It is a bit of learning. You're going to have to work at this in order to understand it, but you can do it, and with a little bit of just keep practicing and doing some examples, you'll become experts at this very quickly. All right, good luck with that.